Hey guys, this is the study guide for exam 4. The first question is asking, for the following function, determine whether it is a one-to-one function. So remember, for a function to be one-to-one, every unique input needs a unique output. And the input is always the x, and the output is the y. So if we put in an x, whatever this function is, we don't really know. If I put in a 4 for an x for that function, I will get out a 9. If I put in a 3, I will get out a 9. If I put in a -8, I will get a 14. And if I put in a 6, I will get a -8. So each x has to have its own y. In this case, 4 goes with 9, 3 goes with 9, -8 goes with 14, and 6 goes with -8. So because both 4 and 3 have 9 as their output, it is not a one-to-one function. Each unique x value has to have a unique y value. So if 4 goes to 9, 3 cannot go to 9 unless it is not one-to-one. We're going to do the same thing here. So the first number in the pair is our x value. The second number is our y value. 7 goes to 7, 8 maps to 8, 9 maps to 31, and 10 maps to 94. That is a one-to-one function because each input has its own output. Number 3 says the graph of a function is given. Use the horizontal line test to determine whether f is one-to-one. So remember a few chapters ago we did the vertical line test. This one is the horizontal line test, but the test is the same. So you just make sure that wherever I am to draw a horizontal line on the graph, that line should only cross the function one time. And that is true here. It crosses exactly one time for each horizontal line. So is it one-to-one? We can say yes, because we tested it using the horizontal line test. Good. It's never in focus enough, is it? All right, here it says the graph of a one-to-one function is given. We know it is one-to-one. Draw the graph of the inverse function. They also gave us the graph y equals x, because that would be the line of symmetry for a function and its inverse. All right, so remember that to find the inverse function, you take every x and y and you flip them, right? So in this case, we have 4 points. We have the point 2, 4. Oh, that is a messed up. Pen. All right, we have the point 2, 4. 2 is the x, 4 is the y. The inverse function, so this would be f of x. The inverse function, we're going to switch the x and the y. So 2, 4 becomes 4, 2. Good. So the point is 2, 4 because we went over 2, up 4. Now we're going to go over 4, up 2. And that'll be the new point. Good. Another point is 1, 2. The inverse of that, the inverse function would be 2, 1. So we flip the x and the y. Over 2, up 1. Then we've got the point -2, 1, which becomes 1, -2. And finally, -4, -4. I'm going to flip the x and the y, but the x and the y are the same, so it's actually going to remain -4, -4. Good. And then you can just connect those dots. And that is the graph of the inverse of the function f of x. So which should it look like? Obviously, it doesn't look like that one. It doesn't look like that one. Is it this one or this one, right? And what you can also notice is that this, like I said, is the line of symmetry. So if it touches, if negative 4 touches the line of symmetry, then the equivalent point negative 4 will also touch it. If from the line of symmetry to 4 is one space up and one space to the left, if we go one space down and one space to the right, we should get the equivalent point. So that means it should match along that line of symmetry. This is the same distance from that center line as this. This is the same distance from the center line as this one. They are equal distances from the center line. So it is graph D for number 4. All right, number 5 says the function f of x, 8x plus 4 is 1 to 1. Find the inverse of f and check the answer. So remember here, hold on. Here, what I did was I took x and y and I flipped them, right? So then that became y went into the x place and x went into the y place. They're still x and y, but we flipped the numbers, right? So if you have the equation, you don't have points yet necessarily, though you could find them. What you want to do is you want to change f of x to y. So f of x equals 8x plus 4 becomes y equals 8x plus 4. And then what you're going to do is you're going to exchange the y for the x and the x for the y. So that's going to become x equals 8y plus 4. And then you're going to solve for y. Just like this is already solved for y, we're going to solve this one for y. Okay? So right now y is being multiplied by 8 and 4 is being added. So what would we do? We would do the opposite, starting with the furthest away. So we're adding 4. We're going to subtract 4. Anything I do to this side of the equal sign, I need to do to this side. So that's now x minus 4 equals 8y. I still need to get y alone. Y is being multiplied by 8, so I'm going to divide it by 8. Anything I do to this side, I should also do to this side. So what I get is, and I'm just going to put the y on this side, because 8 divided by 8 just leaves us with y. Y equals x minus 4 divided by 8, or you can say it's y equals x over 8 minus 4 divided by 8 is the same as 1/2, right? So y equals x over 8 minus 1/2. X over 8, if that doesn't look familiar to you, you can also say y equals 1/8 x minus 1/2. Those are all the same, okay? So the inverse function is f negative 1 of x is equal to 1/8 x minus 1/2, or x minus 4 divided by 8. Either one of those, any of those. Good? Okay, now it wants to know the domain of this one. Remember, the domain is any x value, all possible x values. We see that there is no x in the bottom of a fraction. There's no x being squared. So we're going to say it's all real numbers. You're also welcome to graph this on Desmos. Let me see. I will share my screen. It was f of x equals 8x plus 4. There you go. And you can see as you zoom out is that it is in the x direction, all real numbers. Nothing is omitted, and there's no place where it starts or stops, right? And then they're going to ask us for the range. So on the y-axis, is there anywhere it starts or stops or has any gaps? It does not. And so we're going to say that that domain is all real numbers and that the range is also all real numbers. Good? They want us in interval notation, so we're going to say from negative infinity to infinity. And the range is also negative infinity to infinity. There is no point where x does not exist. Good? All right, the domain of f negative 1 of x is, or the inverse. You can also graph this if you just want to be sure. But we can say 1/8 x, don't put the x in the bottom. That's a different equation. Minus 1/2. And remember, it's just whatever point, if I was turning this into a table, this is going to have the opposite, right? -2, -12. So if I put -12 in here, it will have -2. You see how they are opposites? But we can also see that the green line, 1/8 x minus 1/2, also goes on forever in both directions, has no gaps, and goes on forever up and down. So we are going to say that the domain and the range of the inverse are also all real numbers. From negative infinity to infinity, from negative infinity to infinity. Good. Now it wants you to graph f and its inverse on the same coordinate axis. You obviously won't be drawing it by hand, but what you want to do now is just find some points. And I would just take 8x plus 4 and plug in some very small x values, all right? So it's y equals 8x plus 4, and I'm just going to say when x is equal to 0, even that would be easy, right? Y equals 8 times 0 plus 4, y equals 4. So when x is 0, y equals 4. So that's the point 0, 4. And this is for the graph of f of x, right? And we know that it's a straight line, so we just need one more point, maybe the point when x is equal to 1, right? Y equals 8x plus 4 when x is equal to 1. Y equals 8 times 1 plus 4. That's even kind of big. Y equals 8 plus 4. Y equals a positive 12, right? So that'll be the point 1, 12. You can use that to graph your line. We're going to find 0, 4, and we're going to find 1, 12. You can find a third line just to make sure it matches. Let's find a third line, right? What if it was -1? Y equals 8 times -1 plus 4. Y equals -8 plus 4. -8 and positive 4 is a -4. So when x is equal to -1, y is equal to -4. So that'll be the point -1, -4, just to make sure that those all line up. So I know I didn't make a mistake, or I'm less likely to have made a mistake. So -1, -4, and then draw that line. And that's f of x. Now we need to do the inverse function. So we're just going to take that same fraction that we found. I think it might be easier to use this one if we're just solving for y. So we have y equals x minus 4 over 8 when x is equal to 0. Good? Y equals 0 minus 4 over 8. Y equals -4/8, which is -1/2. So when x is equal to 0, y is equal to -1/2. That might be a little bit small to see, right? Here. So I'll use a different point. Y equals x minus 4 over 8. We will say when x is equal to 4. Yeah? What happens when x is equal to 4? y equals 4 minus 4 over 8, which is 0 over 8, which is 0. So when x is equal to 4, y is equal to 0. So that'll be the point 4, 0. That's a little bit easier to graph than 0, -1. Now I'll find two more points. It looks like, what would be an easy one here? 4 was easy. How about 12? When x is equal to 12, y equals 12 minus 4 over 8, which is 8 over 8, which is 1. So when x is equal to 12, y is equal to 1. So that's the point 12, 1. Good. How far does this go? 20? So I'll do 20. Y equals x minus 4 over 8 when x is equal to 20. 20 minus 4 divided by 8 is 16 over 8, which is 2. So when x is equal to 20, y is equal to 2. So that's the point 22. So for this next, for the inverse, I have 4, 0, 12, 1, and 22. So over 4, not up or down, so 0. 12, 1, and 22. Good. And then you'll just draw that line. And that is the graph of the inverse. Good. All right, number 6 asks us to use transformations to graph the following function and determine the domain, range, horizontal asymptote, and y-intercept of the function. So we have f of x equals 2 to the, oops, sorry, you couldn't see that. F of x equals 2 to the power of x minus 4. Good. All right, so you can just plug in some x values and see what you get for y. So y equals 2 to the power of x minus 4. When x is equal to 0, what is y? Y equals 2 to the power of 0 minus 4. Y equals 1 minus 4, which is -3. So that'll be the point 0, -3. We can then do it with the number 1, right? When x is equal to 1, y equals 2 to the power of 1 minus 4. 2 to the power of 1 is 2, minus 4 is -2. Good. And then we can say 3. Y equals 2 to the power of, oh, sorry, let's do 2. 2 to the power of 2 minus 4. When x is equal to 2, what is y equal to? 2 squared is 4, minus 4 is 0. So when x is equal to 2, y is equal to 0. So that'll be the point 2, 0. You can also look at it on Desmos to see what shape it's going to be, right? So we're back here. We'll get rid of these. And we'll just say 2 to the power of x. And look at 2 to the power of x looks like this, right? And then the transformation would be that We're subtracting 4. So think about, before I write it, think about what is going to change. It's going to go down 4. So from 0, 1, it's going to go to 0, -3. So all of these spots just moved down 4. Good? All right, so we want to graph something that looks like this and that crosses at the points that we found. So the points that we found are 0, -3, 1, 2, 1, -2, sorry, and 2, 0. Good? So that is how we would graph it. Here, here, and here. And what's happening? It's approaching -4, right? But it never touches 0. It just gets smaller and smaller and smaller. So it's going to look like that. And this is just going to go up really quickly. Good? So the domain, all x values, we can see that it's from -infinity to infinity. But the range, the y values, it's not going to cross -4. It's not even going to touch -4. So we're going to start at -4 to infinity. Good? And what would the horizontal asymptote be? The horizontal asymptote is where it approaches and never touches, right? It approaches and never touches -4. The function has one horizontal asymptote at y equals -4. And what is the y-intercept of the function? The y-intercept of the function is where y is equal to 0, right? Nope, the y-intercept is where x is equal to 0. And if you didn't know that already from plugging in points, you can just go to your equation. F of x equals 2 to the power of x minus 4. Put in a 0 for that x. Y equals 2 to the power of 0 minus 4. Y equals 1 minus 4. Y equals -3. So my y-intercept is -3. And it doesn't need to be y equals -3. It just says type in an integer or a fraction. So you don't need the y equals. Good? We're going to do the same thing for number 7. Use transformations to graph the function. Now we have f of x equals 8 to the power of x minus 1. If we were to put this into Desmos, 8, oh, come on. Good. You can pull down a table of values. 1 becomes the x value. When you put 1 in, 1 minus 1 is 0. 8 to the power of 0 is 1. 2 minus 1 is just 8 to the power of 1, which is 8. 3 would be 64. 4 would be 8 to the power of 3, right? So we see that on the negative side, it's approaching 0, but it's never going to touch 0, right? Even if I said -100, that's still not 0. It's just a really big number. Really, sorry, a really small number. So it's approaching 0, but it'll never touch 0. And then on the other side, it's growing really quickly, right? So what is the domain? Use the graphing tool to graph the function. Again, we just want to find some points that we know are on the graph. We know that the point 1, 1 is on the graph. We know that the point 2, 8 is on the graph. And then 3, 64. So you'll probably have to just stick with 1, 1 and 2, 8 in this case. And we can confirm that because we can say y equals 8 x minus 1, 8 to the power of x minus 1. When x is equal to 0, what happens? 0 won't be good. When x is equal to 1, y equals 8 to the power of 1 minus 1, which is 8 to the power of 0, which is 1. So when x is 1, y equals 1. And so that's the point 1, 1. And then we'll try 2. Y equals 8 to the power of 2 minus 1, which is 8 to the power of 1, which is 8. So when x is equal to 2, which we got from right there, y is equal to 8. So that's the point 2, 8. Good. And then you're just going to graph that. And remember, it's going to cross here, and then it's going to approach but never touch 0. What is the domain? The domain is all real numbers, right? So on the x-axis, it goes from negative infinity to infinity. What is the range? It's from and never touches 0 up to infinity. Good? And what is the horizontal asymptote? The horizontal asymptote is y equals 0. And what is the y-intercept? So this is going to give us a fraction, but we can handle it. Don't worry. So remember, the y-intercept is if you make x equal to 0, which I said I would do up here, but I said that was too difficult, so I quit. We'll do it now, though, because they want to know. It's too difficult to graph, I would say. All right. The y-intercept is when x is equal to 0. So we have y equals 8, x minus 1 becomes y equals 8 to the power of 0 minus 1, which is 8 to the power of negative 1, which is, remember, you put it on the bottom of the fraction, and what is 8 to the power of 1 is 8, right? The y-intercept is 1/8 because it's a negative. If it was positive, it would be 8 over 1, but because it's negative, it's 1 over 8. All right, begin with the graph of y equals e to the power of x, and use the transformation to graph the function y equals e to the power of negative x. Get rid of this guy. E to the power of x looks like this, right? It's approaching 0 on the negative side, and it's approaching infinity after we cross the y-axis. And then what's going to happen if we make that x negative? It's just going to flip over, right? So it's asking us to graph the function. It goes from 0, 1. Is there any other good point on it? All right, so you just want to go through 0, 1. And then make it go down on this side and up on this side. Good? And then they'll want you to type an exact answer if you want to put in the points, but you should just use the table or the calculator, right? E to the power of, if you need another exact point, you can either use this or you can say e to the power of negative 1. And then you can type that in as your value when you are graphing it for the exam, right? E to the power of -2. That's how you get it precisely where you want it on the graph, because I know that would be difficult with the letter E. Good? That's why it says, for any answer boxes shown with the graph or type an exact decimal. All right, so the domain is all real numbers. The range is from 0 to infinity. Good. The horizontal asymptote is going to be y equals 0. And the y-intercept of the function, where it crosses y equals e to the power of x. Oh, sorry, -x. Y equals e to the power of -1. Sorry, it's where it's 0. The y-intercept is where x is equal to 0. Y equals e to the power of -x. Y equals e to the power of -0. But -0 is just 0. And anything to the power of 0 is 1. So the y-intercept is just 1. Good? All right. The next part is changing between exponents and logarithms. All right, for this one, remember that we're always going to go in a circle. I'm going to change this to make sure that the exponent's on this side, because that's just what I'm used to. So you have what is called the base number, you have the exponent, and then you have the answer, right? Okay, so you're changing it to log. So what you're going to do is you're going to write log. Start with the base. Good. Put that down here. Then you're going to go in a little circle. So we're going to go to the next term, the answer. Equals, and then the exponent. Good. So the equivalent logarithmic statement of 9 squared is equal to 81 is that the log base 9 of 81 is equal to 2. But of course, it doesn't matter if you write the 2 over here and you left it like that. Good? Okay, same thing. So we've got a base, we've got an answer, and we've got an exponent, right? So we're going to write log, and then we're going to start with the base. Here the base is e, so log base e of 19 is equal to, and we're going to keep going in that circle, x. One more thing you're going to do. Log base e is natural log. So we're going to rewrite it as the natural log of 19 is equal to x. Good? All right, here we're going to change from a log into an exponent. You've got your log, your base, what is your answer, and your exponent, right? So start with your base, 9. Go over to your answer, to the power of 4 is equal to, and keep going in that circle, 6,561. And you can check all of these on your calculator too, just to be sure. All right, after you've done that manipulation, you can go over to any scientific calculator, any calculator that you have, and you can make sure that log and if you have a base that's not 10, what you want to do is put another log under it. And that is how you show that it is a log base 10 of 81 is equal to 2. So that is true, right? We can't check number 10 because we just have an x instead of a value, but we can check number 11 by saying is 9 to the power of 4 equal to 6,561, and we can. Good? All right. Now they're asking us to change it into an equivalent expression using an exponent. So same thing. You've got your base, and you've got your exponent, and you've got your answer. So starting with the base, 4, your exponent is -5. So the 4 to the power of -5 is equal to 1 over 1,024. You can check that in your calculator. Good? So that's the logarithm written as an exponential equation. Here we have log base a of 3 is equal to 2. Again, you want to start with your base, a, to the power of 2 is equal to 3. Good. Now they're asking you to find the exact value of the logarithm without using a calculator. Obviously, the exam doesn't know if you use a calculator, right? But we can rewrite it as an exponent and see if we can figure out what the exponent should be, right? So we're going to start with 8. 8. Oh, no, we need to start with saying is equal to x because we don't know, right? So 8 to the power of x is equal to 1/64th, right? And so then we think about what exponent, what does 8 need to be multiplied? How many times does 8 need to be multiplied by itself to get 1/64? And it is -2. -2 times 8 to the power of, oops, 8 to the power of -2 is 1/64. Because 8 to the power of 2 is 64. So the negative exponent is going to be 1 over that same number. Good. All right, again, they're asking us to find the exact value. So we'll start with that base, 1/4. 1/4 to the power of x is equal to 256. Good. 1/4 to the power of what would equal 256? -1 to the power of -1 is 4. What about -2? It's 16. -3 is 64. -4 is 256. So our answer is -4. And you can also, even though it says don't do it on your calculator, you can check it on your calculator. So the log of 256 divided by, because the base has its own, good? The base needs to be written as its own log that we are dividing by. Good? So the log base 1/4 of 256 is -4. All right. Now it's asking us to determine the domain of f of x equals log base 4 of x plus 1. You can just graph that if you want, but we can switch this back. So we'll start with 4. 4 equals x plus 1. Does that help? Or you can graph it using Desmos. And it's asking what the domain and range would be. You just want to make sure, or sorry, just the domain. So just the x values. What's that going to be? It's going to be from -1 to infinity. Why is that true? -1 plus 1, 4 to the power of y equals 0. Nothing, there's no exponent that is equal to 0, so you have to omit 0, right? And if we were to go -2, 4 to the power of y equals -2 plus 1. That would be 4 to the power of y equals -1. You're never going to have an exponent that's a negative, so it stops there. Good. Number 17 says use the given function to find the domain of x. So we have f of x equals the natural log of x plus 4. What would be the domain? I would say that the domain is from -4 to infinity, right? Which is the correct graph. this one. Because we start at -4 and we go towards infinity. The range, so on the y value, it's all real numbers. So from -infinity to infinity on the y value. And then what would be the vertical asymptote? The vertical asymptote is at x equals -4 because it does not go past or touch -4. Good. What would the inverse of... All right, so to find the inverse, f is f of x equals the natural log of x plus 4. I'm going to switch it over to an exponent, right? So the natural log, if I was to rewrite it, that would be log base e of x plus 4 is equal to y, right? And then we do our switch. So we start with e, go over here. So e to the power of y is equal to x plus 4. So that's our original function, right? E to the power of y is equal to x plus 4. And then you're going to flip your x and your y. So now it's e to the power of x is equal to y plus 4. And then you're going to solve for y. So you're just going to subtract 4 from each side. So it gets you y equals e to the power of x minus 4. Good? So the inverse is f of x is equal to e to the power of x minus 4. If we graph that, what does it look like? It looks like that. So we would say that the domain is all real numbers, -infinity to infinity. The range is from, what is it approaching? It's approaching -4. -4 to infinity. And which one does this look like? This looks like B. Good? All right. All right, for this one, we want to remember the logarithmic properties. So we have the product rule, which is that when they're being multiplied, the log base a of x times y is equal to the log base a of x plus the log base a of y. That's the one we would use here because it's log base 6 of 36x. So we want to express it instead of as a product of logarithms, or instead of an expression as a sum, because we are going to add them. So log base 6 of 36 times x becomes log base 6 of 36 plus log base 6 of x. Good? 19. Same thing. We're simplifying the logarithmic expression. And then the power rule should be expressed as a factor. A factor just means that you're multiplying by it. Okay, so log base a of x to the power of p becomes p. So the p, instead of being an exponent, it's out in front. P times log base a of x. Good. So here our power is 8. So log base 6 of z to the power of 8 will become 8 times log base 6 of z. Number 20. Now we're going to have a difference of logarithms because we're using the quotient rule. So log base a of x divided by y becomes log base a of x minus log base a of y. Here it's natural log, but it's the same thing. So the natural log of x over e to the power of 2x becomes the natural log of x minus the natural log of e to the power of 2x. We're going to take that exponent and we're going to put it out in front. So that becomes the natural log of x minus 2x times the natural log of e. However, if we think about, I should probably be putting parentheses around. If we think about what the natural log of e is, and if we put that into Desmos, the natural log of e is just equal to 1. So we're going to, oh, sorry, I didn't share it. The natural log of e is just equal to 1. Good. So instead of natural log of x minus 2x times the natural log of e, it would be the natural log of x minus 2x times 1, which is just the natural log of x minus 2x, because 2x times 1 is just 2x. Good? All right. Now we're going to write log base c of the quantity u squared times v to the 9th. First of all, we'll turn it into a sum of logarithms. So it will be log base c of u squared plus log base c of v to the power of 9. And then that becomes 2 times log base c of u plus 9 times log base c of v. Now we're going to do the opposite, where we take it from a sum of logs to a single expression, a single logarithmic expression. So here we have 3 times log base 7 of u. That becomes log base 7 of u to the power of 3 plus log base 7 v to the power of 8, right? And then if you want to turn the sum, so first we took that 3 and made it into an exponent again, took that 8 and turned it into an exponent again. And then once you have that sum, you can turn it into a single term. So it's log base 7 of u to the 3rd times v to the 8th. Again, we're going to write it as a single logarithm. Here we have log base 4 of x squared minus 25 minus 6 log base 4 of x plus 5. The first thing I'm going to do is take that 6 and put it up here. I have log base 4 of x squared minus 25 minus log base 4 of x plus 5 to the 6th. Now I'm going to turn it into a fraction. So that becomes log base 4 of x squared minus 25 divided by x plus 5 to the 6th. And then we can simplify that even further. We can simplify this fraction. Log base 4 of x squared minus 25 becomes x plus 5 times the quantity x minus 5. And then down here we have x plus 5 6 times. So that's like there's 6 of these, right? We can cancel this and one of these so that that becomes 5. So our final answer is log base 4 of x minus 5 over x plus 5, not to the 6th, but to the 5th, because we canceled out one of these with that one. One was on the top and the other was on the bottom. Good. All right. Now it says use the change of base formula and calculator to evaluate the logarithm. The change of base formula, logs are usually base 10. So the change of base formula would be when you have log of a b, that's the same as log base 10 or base c of b divided by log base 10 of a. Good. So in this case, it would be log base 10 of 35 divided by log base 10 of 7. You just put that into your calculator. Log of 35 divided by log of 7. And our answer is 1.827. What does it say? Round to 3 decimal places. So I'm going to say that our answer is approximately 1.827. Good. All right, for this one, we're going to use the log equality rule. The log equality rule says that log base b of a being equal to log base b of c means that a is equal to c. Good? So since those have the same base, we can say x plus 1 is equal to 15. So we just took that part and that part, and we were able to drop the log bases. So that 15 is this, and this x plus 1 is this. So we have x plus 1 equals 15, so that means x is equal to 14. We subtract 1 from each side. All right, for 26, I'm going to change this into a single log. So instead of log base 2 of x plus 2 plus log base 2 of x plus 5, I'm going to have log base 2 of x plus 2 times x plus 5 equals 2. And then I'm going to change this to its exponent form. So we'll start with the base 2, go over to this 2 to the power of 2 is equal to x plus 2 times x plus 5. Good. And then 2 to the power of 2 is 4 is equal to, and then we'll FOIL that, x squared plus 2x plus 5x plus 10. 4 is equal to x, and we're just solving for x now. X squared, 2x plus 5x is 7x plus 10. Subtract the 4 from both sides, we get 0 equals x squared plus 7x plus 6. And then I want to factor that. And that becomes x plus 6 times x plus 1 because 6 times 1 equals 6 and 6 plus 1 equals 7. So that's back way back from unit 1. So my answers are x equals -6 when I set those equal to 0 and x equals -1. Now if I put both of those back, do I get positive logs? So log base 2 of -6 plus 2 would be a -4. If I did -1, log base 2 of a -1 plus 2 is a +1. -1 plus 5 is a +4, so that one's okay. So this would be our final answer. The solution set is -1 for 26. Number 27 is asking us to solve the equation 3 to the power of 3x plus 1 is equal to 27. Remember, we want to make the base equal so that we can make the so we can get rid of the base and just set the two exponents equal. So 27, if I think about it, is there a power of 3 that is there a power of 3 that would equal 27? So 3 squared is 9. 3 to the power of 1 is just 3, right? And then 3 to the power of 3 is 27. So I'm going to change that 27 on the right side to just a 3 to the power of 3. So then I have 3 to the power of 3x plus 1 equals 3 to the power of 3. That means 3x plus 1 is equal to 3, and then I'm just going to solve for x. So subtract 1 from both sides, I get 3x equals 2, divide by 3, and I get x equals 2/3. So the solution set is 2/3 for this one. 28. So to find the exact answer for this one, I'm going to change it into log form. 5 to the power of x equals 3 becomes log base 5 of 3 is equal to x. Good. And then if I put that into my calculator, remember, log divided by the base point. The solution set is 0.683. Sorry, they said that they want a integer or fraction. So they do not want a decimal. All right, so instead of that, we're going to take the rule of natural logs and we're going to say if 5x equals 3, that means that the natural log of 5x, 5 to the power of x, is equal to the natural log of 3. And then we're going to simplify that, okay? So the first way we're going to simplify it is we're going to take that exponent and put it out in front. So we have x times the natural log of 5 is equal to the natural log of 3. And then we're just going to solve it for x. So right now x is being multiplied by the natural log of 5. So I'm going to divide both sides by the natural log of 5. And what I get is x equals the natural log of 3 divided by the natural log of 5, which should give us that same decimal, but they didn't want it in decimal form. They wanted it in a integer or a fraction. So this will be the fraction. Natural log of 3 divided by natural log of 5. So now they're saying we can, for 29, solve the following exponential equation and use a calculator. So this time you could just create a log and put it into your calculator. So that's what we did for number 28. You can do for 29. So start with the 5. Oh, sorry. Log base 5 of 36 is equal to x minus 3. What I'm going to do is I'm going to log base 36 divided by log base 5 is equal to 2.2265. And then I'm going to say is equal to x minus 3. What I have to do, my next step is add 3, right? So before I change it at all, I'm just going to take my answer and add 3. So I get 5.22665, so you can say 5.227. And it says round to the nearest hundredth, so you could even say 5.23 would be the correct answer. Good. Or you can try the natural log of 5 to the power of x minus 3 is equal to the natural log of 36. X minus 3 times the natural log of 5 is equal to the natural log of 36. Now I have x minus 3 being multiplied by natural log of 5, so you can say x minus 3 is equal to the natural log of 36 divided by the natural log of 5. Put that into Desmos. And it's that same answer, 2.2222. So 2.2265. And then we will add 3 to it, so it would be 5.2. So either way that you do it, you should get the same answer. And that is the end of our study guide. So it's 5.23. Thank you guys so much, and good job.